everyone, my name is Hubert and welcome to Teach Me channel. Today we are going to learn how to solve linear simultaneous equations. This is a topic that a lot of people struggle with and therefore I decided to teach you how to do that. Today we will cover two methods of how to solve linear simultaneous equations. We will do quadratic simultaneous equations in another maths video. Okay, so without further ado, let's get started. First method to do this is what I like to call common factor method. I'll write it down for you. Common factor method. And that method focuses on getting one of the terms cancelled out, and in that way we will arrive at the solution. I will show you exactly what I mean. So let's start with an example like this. Minus 2x plus 4y equals 22, and its simultaneous equation will be 2x plus y, which equals 13. Now, how do we solve this? How do we get a solution for x, and how do we get a solution for y? Well, what we will be trying to do is to eliminate either x or y, and in that way, by eliminating one of those terms, we'll be left with only one of those terms and the number on the other side, which will easily allow us to work out what that term is. So let's get started. I will show you exactly how to do it. So here, the easiest way to cancel out one of these letters is essentially by cancelling out x. As you can see, here we have negative 2x, and here we have positive 2x. Now, if we add entire two equations together, negative 2x plus positive 2x equals 0. So that way we'll be able to cancel this out. But we will have to add entire equations together to cancel these guys out. So how do we do this? We just add every single term. So we add these two, we add these two, and we add these two. We can add together equations, or we can subtract equations one from another, depending on what will help you cancel out one of those terms. In this case, we'll be adding, because this is what makes sense. This is what will give us 0 in this case. Okay. So, if we add these together, we'll get one big super equation. So here we have 0. So here we have 0, nothing. Here we have 4y plus y. So here we have 5y. And here we have 22 plus 13. So what does that make? That makes 35. And now, as you can probably see, this is much simpler to solve for y. Because all we have to do is some basic algebra. We divide both sides of the equation by 5. Because we're getting rid of that 5 here. So now we have y, which is equal to 7. And that is our answer for y. However, now we need to go back and find out an answer for x. So the easiest way to do this is to substitute this answer back into an equation. So we can pick either equation that we like. This one looks a bit simpler to me. Lower numbers, it looks a bit simpler, so I am going to go with this one, but we can pick any one of those two. So what do I mean? Well, let me copy down this equation. So if we have 2x plus y, I'm going to put it down here, equals 13. Now, we know that y is equal to 7. So, what we are going to do is replace that y here, we replace that y with 7. So now, we can figure out the answer. So, how do we do this? We need to figure out the answer for x. So, first of all, we will subtract 7 from both sides. So, let's subtract 7 from both sides. And that will give us 2x equals 6. So now, what do we have to do? We have 2x and a 6. So we have to get rid of that 2. So we divide both sides by 2. I'm gonna continue here because we ran out of space. So the answer is y equals 7 and x is equal to 3. So that's the simplest way to solve simultaneous equation. We just find a common factor where they are the same, where one of these terms is the same, and then we either add or subtract these equations depending on what will give us that 0 we are looking for, and then just simply algebraically solve the answer for the remaining term, and then substitute that remaining term back into one of these original equations to give us an answer. You could, of course, check it. If you wanted to check it, you could, of course, check it on the other equation. Okay, so this is all well and good. However, what happens if those terms are not exactly the same? Well, there is a relatively simple solution for that too, and I'm going to show you now. So let's take this equation as an example. Let's take, one second, let me think. Okay, let's take this equation for an example. 3x plus 2y equals 12. And another simultaneous equation will be 5x plus 3y, which is equal to 19. Okay, so the problem we have here is that none of these terms are identical. So we can do it quite as simply as here. But what we can do is multiply one or both of these equations within themselves. I will show you how to do it. You multiply one of these or both of these equations to give you the same terms, and then we do it the same way as we did here. So let's have a look at y. Let's have a look at y. Now we can see there is a 2, there is a 3. So now if we can get them both to be 6, then we will get 2 identical terms. So let's do it. Let's do it. So how do we achieve this? We have to multiply this entire equation by 3, and we have to multiply this entire equation by 2. Okay, so let's do it. Let's start with this one. So now we have 9x, 3 times 3, plus 6y as planned, which equals 36. And what do we have here? Here, remember, we are multiplying by 2. So here we have 10x plus 6 again, 3 times 2, 6y. And here we have 38. And now, because we have 2 positive 6y's, we need to subtract. We need to take away. Because both of these y's are positive, so in order to get 0, we need to subtract. So let's do that. So now we can subtract this equation from this one or this one from this one. As long as we're careful with all the signs, that should give us the same answer. But for the sake of simplicity, let's do it from top to bottom. So this equation minus this equation. So here's the minus, here's the minus, and here's the minus. And this will give us following. So 9x minus 10x will give us negative 1x. Here we have nothing. We have 0. And here we have 36 minus 38. So what do we get here? Here we get minus 2. So minus x equals minus 2. Okay. So because they are both negatives, let's give an answer for x. We just get rid of these minuses on both sides. So x equals 2. There we go. So that's our answer for x. And now let's substitute it back into one of those equations to figure out the answer for y. So we can substitute it back into these originals, or we can substitute it into any of those. It should work anyway. But these have lower numbers, so let's make our life easy. Let's do it with this one. Let's substitute it back into here. So what do we get? We get 3x, and x is equal to 2. So we get 6. 6 plus 2y, which is equal to 12. So let's solve this. So now we will subtract 6 on both sides. So let's go upwards here. So now we have 2y, which is equal to 6. And now, of course, divide by 2 to get rid of the 2y. And we know that y must be equal to 3. And there we go. Here we have an answer. Even though we didn't start with the same terms, we multiplied one or both. In this case, we multiplied both of these equations to give us the equal terms, either negative positive or equal both positive or equal both negative. But in this case, we have both positive. We subtracted one from the another entire equations. We got an answer for x this way, and we went back and plugged it into the whole equation, and we got an answer for y. So that's one method of doing this. Now, what if I said that we need to find the solution to a simultaneous equation such as this? Let me show you. Such equation as this. Minus 4x plus 3y is equal to negative 2. And simultaneously, y equals to x minus 1. So now it is difficult because we have letters on both sides. Here it's all good. We have letters all on this side and a sign on this side. However, here we have letters on both sides. So this is a good indicator. If you have letters on both sides, this is a good indicator that as far as linear equations go, you may have to apply a substitution method. I'm going to write it down for you. Substitution method. Okay, and how will this work? Well, here we are given essentially what y is equal to. Y is equal to x minus 1. So we will take this value, x minus 1, and we will plug it in here. We will replace 3y using this in order to have only x's here, and then we can figure out the answer to x. Okay, so how do we do this? Well, let's write down the substituted equation, replaced equation. I will show you how to do it. So we have -4 plus 3y, 3 times y, but this time we are replacing y with this value, with x minus 1. So 3 times x minus 1. 3 times x minus 1, which is equal to -2. Okay, so now, in order to figure all of this out, we need to expand the bracket in order to be able to do anything with it. So, let's do this. -4 plus 3x, because we have 3 times x, and minus 3. And that is equal to -2. Now, sorry, here we have 4x actually. Okay, so now we have 4x and 3x here, and -3. It's just all a bit messy, so let's tidy it up. Let's bring those x's together. -4 plus 3 is still -x minus 3, which is equal still to -2. So what do we do now? Well, simple algebra. We need to add 3 on both sides in order to isolate that x. So now we have minus x, which is equal to +1. So minus x is equal to +1. Well, if we want to find an answer for x, we just need to flip this. So this becomes a plus, this becomes an x, and this becomes -1. Okay, so the hardest work is behind us. This is our answer for x. And now let's figure out our answer for y. And this is exactly the same as before. We have to substitute it into one of those. Whereas here it's kind of a no-brainer because we have y here. It literally gives us an answer for y. So y is equal to x minus 1. So I'm going to just write it here. Y equals x minus 1. Okay. Now we know that x is equal to -1. So let's put that -1 in there. So y equals -1 minus 1. Therefore, y equals -2. Y equals -2. And that is our answer. So this is how we solved an equation, simultaneous equation, where we have at least one part of it, we have letters on both sides of it. We have unknowns on both sides of it. So this is it for today, guys. This is how you solve simultaneous linear equations. Thank you very much for listening. If you're interested in daily science, maths, and university level biomedical science videos, please smash that subscribe button below. If you like this video, give it a thumbs up, and of course, if you have any questions, I'm more than happy to answer them in comment section. Thank you very much, guys. I really appreciate this every time you watch this. Thank you very much, and see you next time.